Section 2.2 is on proportional reasoning, and we're going to start off with 3 vocab words here. A ratio is a comparison of 2 numbers by division, so in other words, a ratio is really just a fraction. A proportion is an equation stating that 2 ratios are equal. So it's a fraction equals another fraction. So for instance, 1/2 equals 4/8. That's a proportion. They're equal to each other. And then the cross product property says that we can multiply across on diagonal in a proportion, and we are going to get the same answer if they're proportional. So the cross multiplying we have to use to solve for example 1 here. We have to multiply the cross product. So y times 84 would be 84y. And then 77 times 12 would be 924. And then we would have to divide both sides by 84. And we would have y equals 11. So that's a way to set up the equation and to solve. Or you can multiply the 2 numbers that are across from each other in the diagonal. So we would do 12 times 77 and then divide by what's across from the variable, which is 84, and we would still get the answer of 11. So it depends on how you want to write it out, how you want to do it, whatever works best for you. 2 different ways to kind of look at it, but you're still doing the same math. Then over here for part B, we have to solve for x. So we are going to do 15 times 7, which is 105. And then we're going to do x times 2.5, which is 2.5x. And then I'm going to have to divide both of those by 2.5. So x equals 42. Again, you could have taken 15 times 7 and divided it by, across from the x is 2.5. You're still going to get an answer of 42. Then we're going to talk a little bit about percents, and you need to know this. We can set up a proportion involving percents. If we take the percent over 100 is equal to a part over the whole. So for example 2, it says at Clay High School 434 students, or 35% of the students, play a sport. How many students does Clay High School have? So we have to set up the 2 ratios. The bottom of the first one is always going to be 100, and the top of that one has to be your percent. So if you look through the problem, you look for that percent sign. We have 35%. So 35 is going to go here. And it says that 434 students, or that's equal to 35%. That's part of the class. We don't, or the whole school population there. We don't know how many they have. That's what they're wanting us to find, is how many students does the high school actually have. So the whole group is the unknown at the bottom. And then we cross multiply. So we're going to do 434 times 100, and that would give us 43,400, and then we have to divide by what's across from the x, which is 35. And that gives us an answer of 1,240. So that high school has 1,240 students. Then we have the vocab word rate. Rate is a ratio that involves 2 different units. So for example 3, a pedometer measures how far a jogger has run. To set her pedometer, Rita must know her stride length. Rita counts 328 strides as she runs once around a 400-meter track. A meter is about 39.37 inches. So how long is her stride in inches? So to start off with, we are going to set up a proportion. And I see that 328 strides is once around a 400-meter track. So there's a rate that we're starting with. And then I know we want to know how many inches is in 1 stride. So we're going to figure out what 1 stride is equal to. So we're setting up that proportion. And we don't know how many meters is in 1 stride, so the x is going to go there. So I put strides at the top because strides was on the top of my other fraction that we started with. If it were at the bottom, then I would have had to put it at the bottom. That's how I knew where to put it. All right, so we're going to have to cross multiply here. And we're going to have 400 times 1, which is going to give us 400. And then x is across from 328. So we're going to have to divide by 328. And 400 divided by 328 is about 1.22. And that's meters because that's what our problem started off in. But it says how long is her stride in inches. So now I need to convert the 1.22 meters into inches. So we set up a conversion factor. It tells us in the problem that 1 meter is about 39.37 inches. Yep. So if meters is on the top like it is here, I want it to go at the bottom so we cancel it out, and I want inches left. And I'm going to use that conversion factor of 1 meter is 39.37 inches. And then I multiply across, the meters would cancel, multiply across the top, so that 1.22 times 39.37 gives me 48.0314. And across the bottom, we're going to get a 1. So roughly just a little bit over 48. So we're going to say about 48 inches is her stride length. Then we're going to talk about similar figures. Similar figures are only similar if their corresponding angles are congruent and their corresponding sides are proportional. So for example 4, we have triangle ABC with the vertices given. Triangle ADE is similar to triangle ABC with the vertex at E of 2, 0. They want us to graph both of these on the same grid. So our x's go up to 8. So 1, 2, 3, 4, 5, 6, 7, 8. And our y's go up to 4. 1, 2, 3, 4. So 0, 0 is A. So there's our beginning triangle. Now it says that they're similar, and triangle ADE is similar to ABC with the vertex at E equals 2, 0. So we're going to plot a different colored point at 2, 0, over 2 and up 0. Sorry about that. People are coming to my door in my classroom and interrupting this. So losing my train of thought as I'm trying to go through these problems. All right, so with that vertex pointed there, we have this side length for our new triangle, and that would be a length of 2. Oops. And then if we look at our starting triangle, it had a length of 8. So if I made a ratio out of their lengths or widths here, we would have 2 over 8. Now we need to figure out how tall our small triangle is going to be, but we do know that this tall triangle, our bigger triangle, is 4. So if I set up another ratio, the big triangle was the distance of 8, so the height has to go at the bottom so that the big triangles are lined up in the same spot in our proportion. So we're trying to figure out what that is. So cross multiply, I'd have to do 2 times 4 is 8, and then divide by 8 because 8 is across from the x, 8 over 8 is 1. So the height of this new triangle is going to be up 1. So that would give me a new point here, and then I can connect that, and we have both of our triangles drawn. Indirect measurement is where we use known lengths, similar figures, and proportions to measure objects that cannot be easily measured. So we're trying to figure out how tall something is that we just can't take a ruler out and measure. So example 5 says a rock climber wants to know the height of a cliff. So let's draw a picture. We have this cliff here. The climber measures the shadow of her friend, who is 5 feet tall. So then I have this other person over here that's 5 foot and is standing beside the cliff and measures the shadow of the cliff. If the friend's shadow is 4 feet long, so the shadow is going to be 4, and the cliff's shadow is 60, so then that shadow from that cliff is coming out. How tall is the cliff? So we're trying to figure out what this is over here. So we can set up a proportion. So I'm going to start off with the cliff, and I have the height over the shadow. And for my other ratio, I have to do the same thing. I have to do the height over the shadow. So then I cross multiply. 5 times 60 is going to give us 300. And then I have to divide that by 4. And 300 divided by 4 is 75. So that cliff is 75 foot tall. Now you may not have set up your original proportion right here the same way that I did, but as long as you keep the same things proportional to each other. So for instance, I could have done the heights. I could have done x over 5, but I started with the x off of the cliff, so I have to start with the cliff on the other dimension, and I could have done 60 over 4. We're still going to do 60 times 5 and divide by 4 and come out with the same answer. So there's lots of ways to set this up. You just have to keep everything lined up the correct way.